Hey everyone, I wanted to go over this example problem from Unit 6. This may help with you doing your DBA problem, modeling exponential growth word problems. So let's look at this example here. Uh, a valuable and rare collector's item is currently worth $5,000. Each year, the value of this item increases by 4%. How many years will pass before the item is worth $8,500? Okay, so this DBA is asking for students to use this particular formula, this exponential growth or decay. And let me just go through the different parts of this formula. We have y equals a times 1 plus r raised to the t. We'll let y represent the final value. Okay, a represents the initial or the starting value of the item. R represents the rate at which the value is either increasing or decreasing. If it's increasing, we want to make sure that it's a plus R. If it's decreasing, we want to make sure that it's a minus R. So the problem will always tell you whether this rate is increasing or decreasing. So we want to make sure that we pay attention to the context of this problem. And then T is time in years. Okay, so how long the time is going to pass before the starting value is going to end up at this ending or final value. And this DBA project is also requiring students to solve this using logs. So even though we could graph and actually find it by looking at the graph, the purpose of this project is to see if students can algebraically know how to use logarithms to solve. Okay. All right, so the initial value is $5,000, so that's going to go in for the variable a. The final value is $8,500, right? It goes from 5,000 to 8,500, so that's going to be the ending value. R is going to be 4%, but there's one thing we need to do. We need to convert rate from percent to a decimal. So the way we do that is whatever percent they give you, we're just always going to move the decimal over two places. So if it's 4%, we're going to make it 0.04. If it's 23%, we're going to make it 0.23. Okay, so you get the idea. We're just moving that decimal over two to the left to convert from percentage to a decimal. So I think we have everything that we need to move forward with our problem. So R gets replaced with 0.04. I'm going to combine some like terms here. So 1 plus 0.04 is 1.04. So now I have 8,500 equals 5,000 times 1.04 to the t. Now let's pay attention to what our purpose of this equation is. Our goal is to solve for t. Okay, so keep that in mind. We want to solve for t. Right? We want to figure out how long will it take before this item grows to from 5,000 to 8,500, right? How many years is going to pass? So now let's think in terms of, we're trying to solve this algebraically. We want to solve for t, but right now there's too many things going on here. We want to see if we can start to clean things up, move things away from this t, and then eventually we may need to figure out how to bring that t down. But first, I realized this 5,000, I can move this 5,000 over to the left side to begin clearing this side up. So if I divide both sides by 5,000, I can use my calculator to clean up or to find out my decimal value here, 8,500 divided by 5,000. And then if I divide both sides by 5,000, that's going to cancel out on the right side. So the left side, the right side just leaves us with 1.04 to the t, and then the left side leaves us with 1.7. Okay, so 8,500 divided by 5,000, we use our calculator, we get 1.7. Okay. So now the next step is we do have our equation a little bit cleaner now, but we still keep in mind that we still haven't solved for t, right? This t variable is still not solved for, but it's kind of in, this variable is kind of in a location that is difficult to work with. Okay, it's a little cumbersome to work with that t. We would prefer to have that variable sitting down in the same level as 1.7 and 1.04. So the question is, how do we bring that t down so it makes it easier to solve? And the answer is we want to use logarithms. Okay, so the advantage of logarithms or logs is if we introduce logs into the problem, we can apply one of the properties, and that properties is bringing that exponent down. So that's what logs is really good for algebraically. It allows us to solve for a variable that is otherwise difficult to work with. So we're going to take the log of both sides, okay? Log base 10 of both sides. In your calculator, you should see a log button. There's also, you can also use your phone. If you use your cell phone and you choose the calculator app, you should be able to turn it sideways and get the scientific calculator to show up, and you'll see logs. On my 36 Pro, log is actually this button here. Okay, tap it twice to get log, and just enter that in. Okay, so we take the log of both sides, but this is where we can take advantage of logs with variables. Now, there's a property that allows, now that we have logs in the problem, we have a property, this power property, that allows us to bring that variable down, okay, without changing the overall value of this expression. So my next step is I want to bring that t down to make it easier to work with. And once that t comes down, now I'm just left with t times log 1.04 equals log of 1.7. I want to solve for t, so I want to divide this over. So I divide both sides by log of 1.04. And when I divide both sides by log of 1.04, the right side cleans up. The left side, we can simply rely on our calculator to do the work for us. So log of 1.7, get that value, plug in log of 1.04, we get that value, and then we divide it. And when we divide it, these two values, we get 13.529. So we know t is in terms of years. So it's going to take about 13 and a half years with this item growing at 4% per year. If it continues to grow by a steady 4% per year, then this item is going to grow from 5,000 to 8,500 in about 13.5 years. All right, so hopefully this will help you out as you choose one of the problems to work out in the DBA project. All right, good luck, everyone.